Hello, my name is Tessa Kelmer, and today I'm going to be talking to you about my project, Geographical Variation of Pantropical Spotted Dolphin Vocalizations. So this is a pantropical spotted dolphin, Stenella attenuata. Its distribution is tropical and subtropical regions ranging from latitude 40 degrees north to approximately 40 degrees south. They have pretty large school sizes ranging from less than 100 to in the thousands. And this includes other dolphin species as well, because they're very social creatures. In the eastern tropical Pacific especially, they are a primary species involved with tuna and dolphin interactions, and they are currently not threatened or endangered and are protected under the Marine Mammal Protection Act. So on the right here, or at least it's my right, we just have a visualization of their global distribution, but my study is focusing on Central America, specifically Mexico, Nicaragua, and Panama. So my data was provided to me from Mexico and Panama, was already analyzed and completed, and that just was given to me by our professor. And the data from Nicaragua I did analyze using Raven Pro software. It came from Padre Hermos in northern Nicaragua, and I analyzed the raw sound files for the different contour types, and the data points of that I placed my focus on were change in frequency and as it relates to the specific contour types. And the overall purpose of my analysis was to determine if there are statistically significant differences between pantropical spotted dolphins at different geographical locations. So just very briefly, these are examples of the sound files that I analyzed. This is an example of an upsweep contour on the left here, at least it's my left. And then on the right is a downsweep, so it's just heading downwards. This is an example of a convex on the left-hand side and a concave on the right-hand side. And then we have the constant frequency, which is just basically a flat line, and then sine, which is a connected like up and down wave pattern. So the results of my analysis, basically to start us off, I just created a percentages of all the different contours within each country. As you can see, Panama, upsweep, downsweep, sine, most common. Mexico, upsweep and convex, most common. And Nicaragua, clearly, upsweep is the most common. Now moving on to my box plots. This one is for the upsweep contour. So Panama has a couple outliers, but is mostly in the lower frequencies. And this is for change in frequency, like overall change in frequency. So Nicaragua had the greatest change in frequency, but Mexico had the largest median change in frequency. Then moving on to sine, we can see Panama is still remaining in the lower frequencies, while Mexico has the greatest change in frequency, and Nicaragua now has the largest median change in frequency, or median change in frequency. And finally, we have our downsweep contour. So Panama, again, very low change in frequency. Nicaragua has the highest overall change in frequency, and Mexico again has the largest median change in frequency. So in addition to the box plots, I also ran an ANOVA test of variance on each of the different contours and their changes in frequency. So for my initial tests, I found that all of the p-values were less than 0.05. So the Panama means for each contour were significantly lower for all three of the contours. So I wanted to see what would happen if I just compared Nicaragua and Mexico. So I took Panama out of the running and just compared Nicaragua and Mexico, and found that the upsweep and downsweep contours both resulted in means having p-values less than 0.05, while the sine contour had a p-value of 0.39. So since the results of the ANOVA test indicate that the means of each of the contours were all statistically significant except for the sine contours of Nicaragua and Mexico, the results indicate that there is a significant difference in the methods of communication among members of the same species that are separated by geographical location. Sorry. So having a better understanding of these whistle vocalizations as it pertains to geographic location could give us a better understanding of communication methods among pod members, as well as interspecies relationships. So, especially now as humans are having a greater and greater influence over the bioacoustic landscape, that affects how these species interact with one another. My recommended next course of action based on these results would be to compare whistles of different species within the same geographic location to see if they are statistically similar.